let's talk about unit tangent vectors and tangent vectors. So here's a function that we've already seen. R of t is cosine t and then 2 sine t. So we saw this earlier, and it gave us a graph that's an ellipse, which looks kind of like that. And the tangent vector, remember this ellipse, it's traveling in this direction counterclockwise. So if we wanted to draw a unit tangent vector, say here, or a tangent vector would just be a vector showing the direction that it's moving in instantaneously. So that's going to be that. And if I drew a unit tangent vector over here, it would be moving straight up at that point. So let's look at finding the unit tangent vector. Of course, tangent is, derivative. So the tangent vector is r prime of t, which in this case is negative sine t to cosine t. And if we want to find the tangent vector at, say, pi over 2 up here, that's going to be r prime of pi over 2. So that's going to be minus sine of pi over 2 to cosine pi over 2, which is negative 1, 2. Or no, negative 1, 0. And that's exactly what this vector is right here. It's pointing in the negative direction for x, 1 unit, and 0 units in the y direction. So that's the tangent vector there. And we could pick any other point on the circle, or the ellipse. Say pick this point here, and its tangent vector would be pointing out here. So that's how you find a tangent vector. Now, a unit tangent vector is just a tangent vector that has a length of 1. So this one right here is already a unit tangent vector. But let's find the unit tangent vector at t equals 0, just for an example. So if we do that, that's going to be r prime of 0. So that's minus sine 0, and then 2 cosine 0. So that's going to be 0, 2. And that makes sense. That's this vector here. It's going over 0 and up 2. So that's a tangent vector. That's the tangent vector at 0. The unit tangent vector at t equals 0 is this vector, but scaled down so that it has a length of 1. So that's going to be 0, 1.